Okay, you should be in your notes in lesson 1-6, and we are picking up where we left off yesterday. We'll do, I don't know if we won't necessarily do all these examples, but we'll at least do one per section, get you guys the basics, and then from there, should have some work time to work on homework. Okay? Did you start the homework a little bit? Yes, no, depends. Okay. So, if you recall from yesterday, we were working with absolute value equations. And we just got into this section where we are going to be talking about checking for extraneous solutions. What do you remember about yesterday? What's the first thing I kept saying all day? Start each problem by doing what? Isolating the absolute value. So if we're going to isolate the absolute value, we want to look at this. So we're looking at problem 3A here. Is the absolute value by itself? And the answer here is yes. Okay, this absolute value is by itself. It's just absolute value of 3x plus 3. Okay, once the absolute value is by itself, then our job is to set up not one, but two equations or inequality. In this case, equations. The first equation is always what? The given one right here. Just drop the absolute value and that's that. So 3x plus 3 equals 4x plus 5. Or, okay. What about the second equation? Partially correct. What? Negative 4x minus 5. Because what you're doing is, on that side that's not the absolute value, you're changing every sign. If it's positive, make it negative. If it's negative, make it positive. So again, absolute value stays as is. 3x plus 3 equals, and then it becomes negative 4x minus 5. So every time you are changing the two pieces. And then we solve, yes? How do you want me to solve that first one? Okay, put our like terms together. If I want to get my, I don't know, I tend to get my x's together first. I've realized, though, in listening to some of you tend to go for putting the numbers together first. Doesn't matter, either way. So if I want to get my x's together, which way do you want me to move my x's? You guys are all quiet today, aren't you? What was it? Okay. She's talking about subtracting 3x from 4x, meaning she's moving her x's so she can keep them positive. Some of you like that. Some of you hate it. Doesn't matter to me. I can do this either way. So if it's positive 3x, subtract 3x. I still have a 3 on the left. 4x minus 3x is x plus 5. Now if it's x plus 5, how do I get x by itself? Subtract the 5. So 3 minus 5 is going to make this negative 2. And x equals negative 2. Or, okay, solve the other one. How do you want to get your x's together this time? Yeah, if it's already a negative 4x, probably better to add 4x. If we add 4x on the right, add 4x on the left. What's 3x plus 4x? So 7x plus 3 equals 2. Negative 5. If it's 7x plus 3, what do I do next? AJ? Yeah, minus the 3. 3's cancel. 7x, negative 5 minus 3, negative 8. Divide by 7, and we have an answer of negative 8 over 7. Okay. With that in mind, am I done? Why am I going to say I'm not done? Have we checked for extraneous solutions? No, we haven't. And that's what we need to make sure we do here. Meaning we need to take these answers, substitute them back in, and make sure they work. So if I take negative 2, you can just do this in your heads. I'll write down some stuff usually, but if I put in negative 2, 3 times negative 2 is negative 6, negative 6, negative 3, absolute value of negative 3 is 3. Okay, I'm writing that 3 down just so I don't forget what I got on the left side. Now let's plug negative 2 into the right. 4 times negative 2 is 4 times negative 2? Negative 8 plus 5? Negative 3. This time, though, there's no absolute value. Does 3 equal negative 3? No, it doesn't. So what's that mean about the answer negative 2? Negative 2 is not a solution. It is what we call an extraneous solution. It's an extra solution. It does not actually work. Okay? So that's how I tend to plug my answers in. Now, officially, what does that mean you need to do here? Plug negative 8 sevenths in. How do you guys feel if I just tell you whether or not it works or not so we don't have to tackle the fraction right now? Okay, I'm going to tell you it works. Probably not what I should do. I should probably force us to try it. But what I will tell you is most of the time in homework, I think they were coming up to be whole numbers when you had to check them, so you won't have to worry about checking fractions, which will be nice. Okay? Now, on this topic, will it always be one works and one does not work? I'll say usually. There are random occasions where maybe both work or neither work, but usually it's just like this where one works and one doesn't work in this situation. Okay? I just don't want you to start counting on it. Okay. Let's set up this next one, and then honestly we can choose to solve it all the way out, or if we want to skip the solving, I'm more concerned, do we know how to do the setup? That's my primary concern here. Because if you know how to do the setup, the solving you should have an idea of already. So, is my absolute value by itself? Yes. So now we're going to set up 2. What's the first one? The given? 5x minus 2 equals 7x plus 14. Or, what's the second one? Miles?
5x minus 2 equals negative 7x minus 14.
Okay, good. Still 5x minus 2. That does not change. And then changing the signs on the right, so negative 7x minus 14. Solving is similar to the last one, correct? Do you want me to go through the solving? Okay. What if I tell you these answers come up to be negative 8 and negative 1? Okay. I'll tell you the answers come up to be negative 8, negative 1. Would I be able to be done right there? No, you would still have to check them. So let's go through the checking real quick so we can get in that habit. If we put in negative 8, 5 times negative 8 is Negative 40 minus 2 is negative 42. Absolute value of negative 42. Positive 42. Now put negative 8 in on the right. 7 times negative 8, negative 56, plus 14. Think logically. What do you know about negative 56 plus 14? It's going to come out to be a what type of number? A negative, yes? What did we have on the other side? A positive. So is this going to work? No. It comes out to be negative 42. But because those aren't equal, I know negative 8 is my non-working answer. Or a non-working answer. Try negative 1. 5 times negative 1 is negative 5 minus 2, negative 7. Absolute value of negative 7. It's positive 7. Okay, put in negative 1 on the right. 7 times negative 1, negative 7, plus 14, positive 7. What did we just find out? Yeah, x equals negative 1 is a working answer. Okay, so that's a little bit more about how to check them. Before we move on to our inequalities, look at example C. Can the absolute value of x minus 5 equals negative 6 be solved? Why or why not? Thoughts? Can absolute value of x minus 5 equal negative 6 be solved? Why or why not? What's your thought? Why yes? Okay. So in terms of the fact it's isolated, we're ready to go, we're ready to set up 2. She's saying yes. Are there any other details there we could think of? Normally when we set up 2, we say the first one is always the given, right? But what is traditionally true about the given? It's usually equal to a positive number here, and this one is equal to a negative. Look at what this equation says. This equation says the absolute value of some stuff, I don't even care what the stuff is, but it says the absolute value of whatever this is equals negative 6. When I take the absolute value of whatever's in there, can it equal negative 6? No, because can absolute value ever equal a negative? No, it cannot. Now, technically, can I go ahead and set up 2 equations and try and solve? Yes, and you'll come up with 1 or 2 answers, I'm not sure which. But what's going to happen? If you test them, guess what? They're not going to work. Now, the shortcut is, because I see absolute value equal to a negative number, I automatically can stop right there. I honestly don't think you have any of this on the homework like this, but it's a good thing to know because it can save you some steps. So, can this be solved? No. Why or why not? Absolute value cannot equal a negative. So that's just a friendly tip to watch out for. Is an absolute value cannot equal a negative. Okay? Okay. One last thing. Our absolute value inequalities. There's 4 of them, 2 on the front, 2 on the back. We'll probably just do 1 from the front, 1 from the back, or at least full out. Okay. Greater than, less than. Same questions as always. is the absolute value by itself. Yes, absolute value is by itself, so what am I going to ask you to do? Make it 2. Now, the first one, you know what to expect. I'm going to say what? Use the given. 2x minus 1 is less than 5. Now, okay, because we're working with inequalities, I need a word from you. We either need to set this up as an and statement or an or statement. And how we know if it's going to be an and statement or an or statement is looking at the sign. What sign is this? Less than. When we talk about absolute value inequalities, you'll hear me say I'm a little different. I emphasize a little different because I call them greater than and less than. Because if you say it right, greater than, that indicates greater than, we're going to use or. Less than, think and. So because this is a less than sign, we're going to use the word and. So that's how you know which word to use. You have to look at the inequality. So 2x minus 1 less than 5. And how's my next setup going to go, you think? Still 2x minus 1. What changes? Okay, flip what sign? Okay, we're going to flip both sides, right? We're going to flip the inequality sign, and we're going to flip positive 5 to negative 5. So we're changing 2 signs is what I always say. Less than becomes greater than. Positive 5 becomes negative 5. Does that sound familiar? You probably saw a little bit of it in Algebra 1. Not necessarily a whole lot, but okay. Can we solve these? If it's 2x minus 1, I'm going to add 1. 2x less than 6. Divide by 2, and x is less than 3. Don't forget your word. And second one. If it's 2x minus 1, I'm going to add 1. So now it's 2x greater than negative 5 plus 1 is negative 4. Divide by 2. X greater than negative 2. Now, and statements. How can we write and statements? Do you remember how to write these from the last lesson? Yep. Put X in the middle. Larger number goes on the right. Smaller number goes on the left. And both of these signs are less than signs. It already says X less than 3. Copy that sign down. And then the greater than negative 2 reverses. So we have negative 2 less than x less than 3. Okay, so less thans are going to turn into and statements. What's the graph of this look like? What kind of dots do we have? They're not equal to, so I'm going to use open dots. They're not filled in. Where's my shading? Out or in? In, because x less than 3 takes me left of 3. X greater than negative 2 takes me right. That means my shadings are going to overlap. Or we want to shade where they overlap in the middle there. Okay. B, let's do the setup. but then we won't actually solve. Okay? Absolute value of 3x minus 4 less than or equal to 8. Is the absolute value by itself? Yes. So now we're going to set up 2. What's the first one? The given. Drop off the absolute value. 3x minus 4 less than or equal to 8. I need a word. What's my word? What kind of sign was this? Less than. And what kind of word does less than use? And. And what's my second inequality look like? Still 3x minus 4. I'll give you that much. What's the rest of it?
Greater than or equal to -8.
Okay, greater than or equal to -8. Both signs switch. Okay, I trust you could solve those if I asked you to. It's an and statement, so again, the shading would be in the middle. Okay, let's look at the back side. Okay, absolute value of 2x plus 4 greater than or equal to 6 is the absolute value by itself. So we're going to set up 2. What's the first one? 2x plus 4 greater than or equal to 6. I need a word. Or, because this sign is greater than. To me, that's the easiest one to recognize. Since it's greater than, I'm going to put the word or in the middle. And, what's my other inequality? Still 2x plus 4, but instead of greater than, less than or equal to, instead of 6, -6. And now we're going to solve. If it's 2x plus 4, you should be subtracting 4. 2x greater than or equal to 4 minus 6 is, it's not 4 minus 6 though, is it? It is 6 minus 4, which does make it positive 2. Divide by 2, and x is greater than or equal to 1. Carry your word down. My word is or. Solve the next one. If it's 2x plus 4, subtract 4. 2x less than or equal to -6 minus 4, which is -10. Divide by 2, and x is less than or equal to -5. Do I put these together in one compound inequality? No, it's an or. When it's an or statement, the best you can do is write the two separate inequalities with the word or between them. And let's graph it. X greater than or equal to 1. Where's that going? Filled in circle to the right of 1. x less than or equal to negative 5. Where does that go? Filled in circle to the left. Notice it's an or statement. My shading went out. Okay, are we getting the hang of this? D, you want to do a quick setup? I don't even know if we need to at this point. We've set them up several in a row, so kind of either got it or don't got it. 5x plus 10 greater than 15. What's my word? Or, because again, it's greater than. And then 5x plus 10 is what? Less than negative 15. Okay. And when you do your graph, realize again it would go out. Okay. You've got just a slight bit over 15 minutes. Just because the announcements start does not mean you will have to stop working. You can keep working for a little bit. So you've got some time. Use it. Practice 1-6 workbook 1 through 20.